Welcome to a journey through the most fundamental and fascinating points of physics. Today, we'll explore 5 key concepts that shape our understanding of the universe. From the ultimate speed limit set by light to the mysterious dual nature of particles, these ideas have revolutionized science and continue to inspire curiosity. Whether you're a science enthusiast or just curious about how the world works, these principles will open your eyes to the hidden rules that govern everything around us. Let's dive into the wonders of physics and see how these concepts connect to our everyday lives and the cosmos itself. First up is the speed of light, one of the most iconic numbers in all of science. In a vacuum, light travels at exactly 299,792,458 meters per second, a value so fundamental that it's used to define the meter itself. This speed, often symbolized as c, is not just fast, it's the ultimate speed limit for the universe. According to Einstein's theory of special relativity, nothing with mass can ever reach or exceed this speed, because doing so would require infinite energy. This limit shapes everything from how we communicate across space to the very structure of reality. Why is the speed of light so important? It's not just about how fast light travels. This speed acts as a cosmic speed cap, influencing everything from time to space itself. When objects move close to this speed, strange things happen. Time slows down and lengths contract. This isn't just theory, it's been confirmed in countless experiments, from particle accelerators to GPS satellites. The speed of light is woven into the very fabric of the universe, making it a cornerstone of modern physics. Next, let's talk about one of the universe's most unbreakable rules, the conservation of energy. This principle, known as the first law of thermodynamics, states that energy can never be created or destroyed. Instead, it simply changes form. For example, when you drop a ball, its potential energy turns into kinetic energy as it falls. This law is at work everywhere, from the food we eat to the stars shining in the night sky. It's a powerful reminder that everything is connected through the flow and transformation of energy. Think about your daily routine: eating breakfast, riding a bike, or charging your phone. In each case, energy is simply changing from one form to another. The food you eat contains chemical energy, which your body turns into movement and heat. Your phone's battery stores electrical energy, which powers its screen and apps. This constant transformation is what keeps everything moving, both in our lives and across the universe. Gravity is something we all experience, but its true nature is more surprising than you might think. Isaac Newton described gravity as a force pulling objects together, like the Earth holding us on its surface. But Einstein's theory of general relativity took this idea further, showing that massive objects like planets and stars actually bend the fabric of space and time around them. What we feel as gravity is really just objects following these curves in spacetime. Imagine space and time as a giant, stretchy fabric. When you place a heavy object like a planet on this fabric, it creates a dip. Smaller objects like moons or satellites move along these curves, which is what we experience as gravity. This idea has been confirmed by observing how light bends around massive objects and how planets move in our solar system. It's a mind-bending concept that changed our understanding of the cosmos forever. Now let's enter the strange world of quantum physics. Here, things don't always behave the way we expect. Light and tiny particles like electrons can act both as waves and as particles, depending on how we measure them. This is called wave-particle duality. It's famously demonstrated in the double-slit experiment, where particles create patterns like waves when not observed, but act like individual particles when watched. This duality is at the heart of quantum mechanics. Double-slit experiment is one of the most famous demonstrations in physics. When light or electrons pass through two tiny slits, they create an interference pattern on a screen, just like waves in water. But if you try to observe which slit the particle goes through, the pattern disappears and they act like particles. This experiment shows that the act of measurement itself changes reality at the quantum level. Quantum mechanics doesn't just stop at wave-particle duality. It introduces a world where particles can be in multiple places at once and outcomes aren't certain until measured. This uncertainty is a fundamental part of nature, not just a limitation of our tools. It's what makes quantum physics both fascinating and puzzling, challenging our everyday intuition about how things should behave. Let's move on to entropy, a concept that explains why time seems to flow in one direction. The second law of thermodynamics states that the total entropy or disorder of an isolated system always increases over time. This is why things naturally go from order to chaos, like a dropped glass shattering but never reassembling itself. Entropy gives time its arrow, making the past different from the future. You see entropy in action every day. When you mix cream into coffee, it never separates back out on its own. When you clean your room, it takes effort, but it gets messy again naturally. This tendency toward disorder is a fundamental rule of the universe, shaping everything from the aging of living things to the fate of stars and galaxies. These 5 principles, light speed limit, conservation of energy, gravity's true nature, wave-particle duality, and entropy, are deeply connected. Together they form the backbone of modern physics, explaining everything from the smallest particles to the largest galaxies. Each concept builds on the others, creating a rich tapestry of understanding that scientists continue to explore. Physics isn't just theory, it powers our technology. The speed of light limits how fast information travels on the internet. Conservation of energy is crucial for designing efficient engines and batteries. Quantum mechanics underpins everything from lasers to smartphones. Even our understanding of gravity helps us launch satellites and explore space. These principles are the foundation of our modern world. Nature is a living laboratory for physics. The way rivers flow, how plants grow toward the light, and the orbits of planets all follow the laws we've discussed. Even the colors of a rainbow or the twinkle of stars are explained by these fundamental rules. Physics helps us see the hidden order in the chaos of the natural world. Humans are part of this universe, and physics connects us to everything around us. Our bodies obey the laws of energy and entropy, our technology relies on quantum mechanics, and our place in the cosmos is shaped by gravity. Understanding these principles helps us appreciate our place in the grand scheme of things and inspires us to keep exploring. At its core, physics is about curiosity, asking questions and seeking answers about how the world works. Every discovery opens new doors, leading to more mysteries and deeper understanding. Whether you're looking at the stars or the tiniest particles, physics invites us to keep wondering and keep learning. Experiments are the heart of physics. From Galileo's falling objects to the Large Hadron Collider smashing particles together, experiments test our ideas and reveal new truths. They help us confirm theories, discover new particles, and even challenge what we thought we knew. Physics is a living science, always growing through observation and testing. Looking ahead, physics will continue to shape our future. From clean energy solutions to exploring distant planets, the principles we've discussed will drive innovation and discovery. As we push the boundaries of knowledge, new technologies and ideas will emerge, changing how we live and understand our universe. Let's recap the 5 fundamental points of physics we've explored. The speed of light is the universe's speed limit, the conservation of energy, gravity as the bending of spacetime, the wave-particle duality of quantum objects, and entropy's role in the arrow of time. Each concept reveals a different aspect of reality, together forming a powerful framework for understanding the world. Physics is an endless journey of discovery. As we learn more, we realize how much there is still to explore. The universe is full of mysteries waiting to be uncovered, and each new insight brings us closer to understanding our place in the cosmos. Stay curious, keep questioning, and remember, the adventure of physics never truly ends.